Hello campers, welcome to the next topic in physical science, and this is a physics one. It's called the equations of motion, and this is our introduction. Now, when we did the motion graphs quite a while ago, we were introduced to our first equation of motion. We were given velocity equals distance over time, v equals s on t, but we were also introduced to the formula for acceleration, which was final velocity minus initial velocity divided by t, given as a equals v minus u on t, or on our information sheet you'll see it as v equals u plus at. And we were able to use that in a number of situations, but we're going to push it a little bit further, or a lot further this time, introduce you to all the other equations of motion, and then do a whole lot of worked examples. So hopefully you'll feel fairly confident at doing these types of questions. There is a little bit of maths involved, so if you're a little bit weak in maths, make sure you follow how I've worked through, and I'll try and show most of the steps of working, but if I've jumped across something, just make a note and give me a holler in class and I'll show you what I did. The math skills aren't exceptionally high, you just need a bit of practice to get them up to speed. So these are our equations of motions. We've done v equals s on t, or s equals vt. We've looked at that before, and then they were for uniform velocity, but when we introduced acceleration, and we're considering situations of constant acceleration, so uniform acceleration, we can then derive these equations here. And the main ones we use are these three here, which we would call the equations of motion, and they're on your information sheet. And just to make sure that you're familiar with what they all stand for, u is initial velocity, v is final velocity, the acceleration is a, t is time, and s is displacement. And this is what it looks like on your information sheet. So you're given these three, and you're given the v equals s on t for constant velocity as well. This one here we don't use too often, but it's basically just saying a rearrangement of this, where the average velocity is, of course, if you're averaging two numbers, you add them together and divide by 2, and that's all it's doing there. So just back to what we're going to be using, these ones here. Now the trick to using these questions is the number 3. 3 is the magic number, because we now have in these 5 unknowns, v, u, a, s and t. But in any one of these equations there is only 4 unknowns, or 4 variables is probably a better way of saying it. So this list here are the 4 variables that are in the equations, and the property that's in the brackets, s, v and t, are the one that's not in the equation. So what I'm trying to do here is show that when you look at your questions and work out what you're given, what you've got to work out is, what are you given out of the 5 possibles, what are you looking for, and therefore what equation do you use. Now obviously if you're looking for s, you can't use this equation. If you're looking for v, you can't use this equation, and t for this equation. But we can move them around and we can solve them. And I'm going to do quite a few examples, so hopefully you'll get the idea. But so when you're reading a question, because there's 4 in each equation, you need 3 to solve for one unknown. And that's why 3 is the magic number. As soon as you identify 3 physical things, you can solve the question. If you're reading a question and you can only spot 2, the third one will be hidden somewhere. Maybe presumed knowledge, or it may be hidden in the wording. So just look out for little traps that await you. So let's do a couple of examples here. Where have my pens gone? Alright, I'm just going to have to pause and find my... Right, found my pens. They magically appeared. So let's just go through it. Now what I'll do first, let's just see if I can do this, is let's just highlight the information that we have. So a car starts from rest. Now that's a piece of information, because that's the initial velocity. Reaches a velocity of this. So there's another piece of information. That will be our final velocity. In 8 seconds. So there's a time. So we're given U, V, and T. So we now have our magic 3 numbers. What can we do with that then? Okay, now I think I've got some writing already ready to appear. Okay, now what they've done here is they've converted kilometers per hour to meters per second, because I would encourage you to pretty much work in meters per second for most questions. It just becomes a good habit to get into, and you've got to make sure you're using standard units as you go through. And what are we asked? Assuming the acceleration to be constant, calculate the acceleration and calculate the displacement in this time interval. So here's the working already done for me. So I've recognized in the question, let's get rid of that writing now, that we've got U is 0, it's at rest, V is 16.67 meters per second, S is unknown, A is unknown, and T is 8 seconds. And I like to write my unknowns down here, get into the habit of this, and then I'm assigning numbers to letters, and make sure you write the units, because it's good practice, and that way you can start spotting things that you're given if you can memorize the units. It's just good practice. So we have our magic number 3, and part A, we want to find the acceleration. So we've got U, V, and T. Looking at our equations, we're going to use A equals V minus U divided by T, which is just a rearrangement of the one on your information sheet. V equals U plus AT. I could have used that in that form as well. Put the numbers, write the equation, put the numbers in, and then we get the answer. And remembering that acceleration is meters per second to the minus 2. And we always write our units in at the end. Now B is asking for the displacement. So effectively now we've got 4 things, because we now know A. And so we can use S equals UT plus half AT squared. But we could have also used the formula. Let's see. We could have also used, whoa, that's a bit crazy. V squared equals U squared plus 2AS. Okay, because we have enough information. We have 3 of the 4 variables in there, so we could use that. Your choice. Sometimes there's more than one way of answering a physics question. That's just the way physics works. It's fantastic like that. I think so anyway. Alright, so magically that's my handwriting, and if you want a neater version, it's going to appear here. There you go. So you can have a look at that, you can pause it, have a look through it again, make sure you're familiar with how it's done. Let's do another example. Let's get my pen out and let's just work out what we're given. Let's read. Usually I recommend students have a go at reading the question a couple of times first. First time to understand the question or to picture it in your mind, so read it all the way through. The second time, just to make sure that you've got everything in terms of your understanding, and the third time you go through and you look for the information that you're then going to use to solve the question. And as you get more practiced, you don't have to read the question 3 times. It becomes second nature to you. So let's just have a go at reading it first. A train starting from rest travels 30 meters in 6 seconds. Find A, its acceleration, and B, its velocity after the 6 seconds. So now we've read it. It's a train starting from rest, accelerating, moving a distance. Okay, I can picture that. Let's look for the information now that we're going to use. And we're going to be looking for, we need to look for, let's just see if this works. We're looking for U, V, S, A, and T. And this is why I like to write that there. Okay, and so we're looking for that. So we've got starts from rest. Now that's a tricky way of just saying U equals 0. Travels 30 meters, so that's our S. In 6 seconds, so that's our T. We're going to find A, that's our question, and we're going to find our final velocity, that's our question as well. So we've got our magic 3 things, haven't we? So let's have a look at what that looks like. So if we put those 3 things there, and we would then recognize that we're looking for, A, and the formula to use that's got U, S and T in it, as well as A, is going to be S equals UT plus half AT squared. So that's the formula. That's the tricky part, recognizing what formula to use. And that's why you've got your information sheet. Okay, or you can go back a little bit and have a look at that bit that I told which ones have which unknowns. And notice here, I've then underneath the equation we put the numbers in. Now UT is going to be just 0 because the initial velocity is 0, and I like to put my numbers in brackets because there's this square here. This square is only the square of the t, it's not the square of anything else, and sometimes students want to use this square to square everything else, so look out for that, and that's why I've put it in brackets. It also helps a marker recognize that you can put the values in the right place. I then simplify it down, so we get 30 equals 18a, that's what this becomes, and by then dividing by 18 I get a equals 1.67. Again, writing in the correct units. You'll lose marks if you don't write in the units, you'll lose marks if you write in the wrong units. Then in B we're finding the velocity, and there's two ways of doing it. Now that we've got 4 of our 5 unknowns, V equals U plus AT is the simplest. Again, putting the numbers into the brackets, getting 10 meters per second. But I could have used V squared equals U squared plus 2AS. There's no problem in using that. This is how I'd put my numbers in. Ends up with being the square root of 100, and therefore 10 meters per second. Same answer. It's physics. It works. So if I click this, a nice neat version should appear. Make sure you understand that. Pause it, have a look at it, have a read of it. If you're not following it, ask me some questions. And there's the neat version of it as well. So you can pause if you need to have a quick look at that. So now you should be able to do the equations of motion questions. Alright, which I'll give you in class. And in the next video we're going to be looking at vertical motion. Cheerio!